welcome to this KOSEN Mathematics 2016, and we're going to discuss about number 1. So about number 1, there are about 12 questions in part 1, and yeah, let's discuss all of them. So this is part 1, number 1. They say let x equals 3 plus root 3 over 3 minus root 3 and y equals 3 minus root 3 over 3 plus root 3, and we calculate x squared minus y squared. Now we can just directly square it and then minus with the square of this, but just let's do it in the algebraic way where you dissolve it into x plus y and x minus y. So because x is that, and we just directly add it with the y. This is probably just maybe the simplest question, right, in the KOSEN Math 2016. And if you do this correctly, then you might get the correct answer. So this is equal to, we just times, and to get the rationalize the denominator, so we multiply that 3 plus root 3 and 3 plus root 3. It's 9 plus 3 plus 6 root 3, then plus this is multiplied, so that is 9 plus 3 minus 6 root 3, and that is over this one times this one, which is 9 minus 3. One more, which is 9 plus 3 plus 6 root 3, and we subtract it with 9 plus 3 minus 6 root 3, and also we get a similar denominator. And now we just calculate that, which is 12 plus 12, right, which is 24 over 6, and this is 9 plus 3 plus 6 root 3 minus 9 minus 3 plus 6 root 3 over 6. So we just, this is 0, so that is 24 over 6 multiplied by 6 plus 3 plus 6 root 3, that is 12 root 3 over 6, so that is 8 root 3. So the answer for number 1 is 8 root 3. Let's solve to number 2. They say we have to solve the equation of x cubed minus x squared minus 10x minus 8 equals 0. Now here, if you get a cubic equation, my recommendation is you look at the final constant, that is minus 8. What I mean is, minus 8 is just the combination of multiplication, such as minus 1 times 8, then for example 1 times minus 8 and others. What I meant to do is, if you, let's say, substitute 1, for example, to this equation, if you get 0, then that is one of the factor of this cubic equation. So let's say we inserted 1. So 1/3 minus 1 squared minus 10 minus 8. Is this equal to 0? So let's see, 1 minus 1 minus 10 minus 8. Well, apparently that couldn't be 0, so that would be minus 18. So let's try minus 1. Minus 1 cubic minus minus 1 squared minus 10 times minus 1 minus 8. Well, this will be equal to minus 1 minus 1 plus 10 minus 8, and this would be equal to 0. So what do we get here? We know that minus 1 is one of the cubic in this one of the factors in this cubic equation. So x third minus x squared minus 10x minus 8, okay, this is equal to x plus 1 times what, right? So we need to find this to find another x. And to do that, we can use the Heron equation. So Heron comparison. First, you jot down the consonant. So this is 1, the constant, there is 1x third minus 1x squared minus 10x and minus 8. and this is, you put like this, x plus 1 equals 0, so x minus 1. So just the same, and you put it here. You put this one down. The first, you directly put it down, okay? Then minus 1 times 1 is minus 1, and this you add it, minus 1 plus minus 1, minus 2. Minus 1 plus minus 1 multiplied minus 2, 2, and then you add minus 8, minus 1 times minus 8, 8 is 0. So you get this one. Now, if you first come up with the cubic equation, the answer would be in the quadratic equation. So the degree of this order of the exponent is decreased 1. So that is 1x squared minus 2x minus 8. So in the end, from that, we got that x third minus x cubic minus x squared minus 10x minus 8 equals x plus 1 times x squared minus 2x minus 8. Now we need to just factorize that, x plus 1, so that is x plus 2, x minus 4. So we just get the root. X plus 1 equals 0, x plus 2 equals 0, and x minus 4 equals 0. It is x equals minus 1, x equals minus 2, and x equals 4. So solve the equation of that cubic equation. X equals minus 1, 2, and 4. So that is the answer for number 2. Now for number 3, it is about trigonometry now. 2 sine squared x minus cosine x equals 1. We just have to solve which one of this angle here make this equation to be true. Now, we first, it's when we look at this equation, we just want to make the variable similar, because this is in sine and this is cosine, and this we can turn it into 1 minus cosine squared x minus cos x equals to 1, so that is 2 minus 2 cosine squared x minus cos x equals 1. Okay, now let's assume that cos x equals y. My purpose is to make this equation, this calculation, become much simpler. So 2y squared, this is y equals 1. So we can change it to y squared plus y minus 1. And now we just need to factorize it. Now, here's the way to factorize on the quadratic equation, which the constant of the squared variable here is more than 1. If the type quadratic equation is like this, is such easy, right? But what about this one? What you need to do is you multiply the constant of this squared variable and the sole constant, that is minus 2. 2 times minus 1, and then you jot down the constant in the single variable, which is 1. And now you need to find the number which something multiplied by something equals minus 2, and that same number when added equals 1, right? Quite easy. That is 2 times minus 1, right? Because 2 times minus 1 is minus 2, while 2 plus minus 1 is 1. Now you get that into this way. 2y plus 2, 2y minus 1. But you divide it by 2, by the constant here. Okay, so that is equals to y plus 1 and 2y minus 1. Right, so you just divide by 2, by the one who can divide it. And we got our simplification here, our factorization. Okay, now to find the x, just change this y into cosine x. So y plus 1 equals 0, and then cosine x plus 1 equals 0, cos x equals minus 1. Now, what value that makes x equals minus 1? I mean, what angle? Well, the only value is actually pi, 180 degrees. And now for the another factorization. 2 minus 1 equals 0, 2y equals 1, y equals half, cosine x equals half. So the value of angle which make it 1/2 is x when it is pi over 3 and 5 pi over 3. So the solution for number 3 is x equals pi over 3 pi and 5 pi over 3. Okay, so that is about trigonometric equation from number 3. For number 4, it is about exponent and logarithm. It is about 2 to the power of x plus 2 plus 3 times to the power 2 to the power of x minus 1, and that is equals 0. Now, just try to make this question simplified, because if you remember the characteristics of exponent, if you have a to the power of m plus m, this is equals to a to the power of m times a to the power of n. So this one equals to 2 to the power of 2 times x plus 2 to the power of 2. Multiply. Okay, this is multiplication. Plus 3 to the power of 2x minus 1. And this one, 2 to the power of 2x, remember that a to the power of bx equals a to the power of x bracket b. And this could be interchangeable depending on the question condition. So this will become 2 to the power of x squared times 4 plus 3 to the power of 2x minus 1. And now to ease the calculation to find for x equals what, we just assume that 2 to the power of x is y. So y squared times 4 plus 3y minus 1 equals 0. And we just use the method to try to find the factorization. When we multiply this constant, so that is minus 4, and we jot down the single variable there is 3. So we just find the same number which multiplied becomes minus 4, and which added is become 3. So the answer is 4 and minus 1. 4 times minus 1 is minus 4, and 4 plus minus 1 is 3. So we can get 4y plus 4 and 4y minus 1 divided by the constant of the quadratic variable here. So that is y plus 1 and 4y minus 1. And now you can this quadratic equation and try to find the value. Now we can convert the y, because y plus 1 equals 0 and y equals minus 1, and we just convert it to the power of x, right? Because they asked us to find the x. So it is 2x equals minus 1. But there is no value of x that is equals minus 1. So this equation turns out not useful. And for 4y minus 1 equals 0, so 4y equals 1, y equals 1 over 4. So 2x, 2 to the power of x equals 2 to the power of minus 2. So x is minus 2. So that is for number 4. And now for number 5, there's an inequality there, that is logarithm with a base of 3 x squared is less than logarithm with base 9 x 4, and we need to find the solution for x and how x will be fit in this calculation. And now for this logarithm, we just need to understand that about the identity of the logarithm. Just remember that when you have logarithm 3 to the power of 2, so the base is turning into the exponent form, right? And x to the power of 4, this is equal to 4 over 2 logarithm with base 3x. Okay, so the exponent in here is above, and the exponent in the base of the logarithm is in the denominator. So it turns out to be this form. So this is less than 2 logarithm with base 3x. And now to ease the calculation, we just assume that logarithm with base 3x is y. So y squared less than 2y. So now we can find it. So y squared minus 2y less than 0. So y minus 2 equals 0. We factorize it. So there is y equals 0 and y equals 2. Since y is logarithm with base 3x equals 0, and for this one, x is 1. Remember, any logarithm with any base, and here the number is 1, that is always equal to 0. So x is 1, and logarithm 3x equals 2. So x is 3 to the power of 2, right? Is it 9? And now, for logarithm itself, if there is an inequality here, we determine the x variable inside of these two logarithm because they are the same. They are the same x, so x must be greater than 0. Now, because it's an inequality, there will not be an exact value like previous number, but we have to find the interval. Okay, so we put here number line. Okay, there's a 0, 1, and 9. Okay, now the number must be greater than 0. Okay, so we made this one. And now, if let's say we take a number here, for example, let's take a number that is divided by 3. For example, let's say we take 3 here. Okay, so 3 logarithm 3 is 1, so that is 1 squared. So let's say I make it like this. So logarithm 9, 3, 4, right? This is equal to 1 squared. And they say that this is less than logarithm 9, 3 to the power of 4. What we do is we just make it like this. So 3 to the power of 2, 3. This is equal to 1/2 times 1. I mean that is 4 over 2 because the 4 is inside times 1, which is 2. So 1 is less than 2. So this is correct. So we trace the area between 1 to 9. So if we found a number between interval of 1 and 9, and we found that the number that we substitute, for example, 2, 3, or 4 until 8, the answer, the x would be suited to this logarithm. But the quick tip is, if you find this interval is okay, I mean it is correct for this equation, the next interval, 0 and 1 and 9 to infinity, it will not fit to this equation, right? For example, if we put, let's say, 1 over 9 here, right? So 1 over 9 between 0 and 1. If we put that in, so 3 logarithm 1 over 9, which is minus 2 squared, which is 4. And then logarithm 9, this is 1 over 9 to the power of 4. So that is minus 1. This minus, yes, maybe minus 4. This isn't correct, right? So the next interval is not the answer. But the interval here, next less than 0, it is the interval. But there is no real infinity value here. So the answer is to be between 1 and 9. So 1 less than x and less than 9. So that is the answer for number 5. Number 5. Now let's go to number 6. Number 6, we have the inequality of trigonometry now. Sine 2x greater than root 2 sine x. And we have the interval of the angles between x, between 0 and 2 pi. Now we just change, because the identity of trigonometry, sine 2x equals 2 sine x cosine x greater than root 2 sine x. We can cross it here. So 2 cosine x greater than root 2. So cosine x greater than root 2 over 2. And now we just need to find what is the angle that's weighted, that is greater than root 2 over 2. Now we need to know that cosine 45 is root 2 over 2. And if we change it to radian, that is pi over 4, 2 over 2. And another value that is also equal to root 2 over 2 is actually cosine 315 degrees angle. So that is also equal to the, in radian, you can just calculate it with 315 pi over 180. Okay, and you divide it with 45, so it is 7 pi over 4. So there are the value of pi over 4, okay, and 7 pi over 4. If you take the value from 0 to pi over 4, all of these are greater than root 2 over 2, right? Because cosine 0 is 1, cosine 30 or pi over 6 is half, and yeah, that is greater than root 2, I mean this is half root 3, that is greater than half root 2. So this is the interval 0 less than or equal to x and less than pi over 4. And now, as the quick tip, if you find this interval suited to the equation, the next interval will not be suited. This is wrong. Because the factual is, if you have the cosine from 90 degrees above to until 270 degrees, the value is negative, right? So this interval is not suited. But the next interval, 7 pi over 4 until 2 pi, is suited with this equation. So that is 0 less than or equal to x or less than pi over 4, and the interval of 7 pi over 4 less than x and 2 pi. So that is the solution for the inequality, for the trigonometry inequality. And now for number 7, we have a vector question. A equals 1, 2, 3. This is the coordinate, right? The vector B has the coordinate of 3, 2, 1, and the vector C has the coordinate 5, 4, 3. And now we have to find the value of t such that the vector A plus TB is parallel to C. Now, to do this question, we have to know the principle of vector, especially of parallel lines, okay? Now we have A plus TB. This means that this is the vector equation between vector A, I mean the point A and the point B, right? So we know that A is 1, 2, 3. We can make this coordinate vector into column vector. So this is 1, 2, 3. This is called the column vector, and plus T, and B is 3, 2, 1. And they say this is parallel to C. C is 5, 4, 3. And remember, if parallel, this means that this is actually, I'll explain that this is x coordinate, this is y coordinate, this is z coordinate, sorry, x coordinate, y coordinate, and z coordinate. Now the x coordinate of one vector must be equal to the x coordinate in another vector, so that the two vector is parallel. So 1 plus 3t equals 5, 5x I mean, because why would I put it x? Because when you have a parallel line, for example this line, let's say this is A plus TB, right? This longer line, if it has the same direction, this is also a parallel line. So we didn't know whether the line of C is really 5 or it is a multiple of 5, right? But with the direction. So I said it is 5x. Same with the y, 2 plus 2t equals 4x, okay? And 3 plus t, 1t equals 3x. So let's find it with the elimination method. Let's use these two equations. 1 equals 5x minus 3t, and 2 equals 4x minus 2t. Okay, we can find it with the maybe times 2 times 3. This 2x equals 10x minus 6t, then 6 equals 12x minus 6t, and this value maybe you can subtract it, and you get minus 4 equals minus 2x. So x is 2. Now when you get x is 2, you get the t. X is 2 from 5x. 1 plus 3 equals 10. So 3t equals 9. So t is 3. So from this coordinate vector, to find the vector that is parallel from a plus tb and c, just remember that the coordinate x must be equal, and you find the t. Okay, so that is for number 7. And now for number 8. Number 8 is related with the, geometry transformation maybe, because it is a very unique question here. Let's say you have an origin. Okay, let O is the origin, 0.0, and A is 3.1. So let's draw just simple coordinate here, 3.1. Okay, so that is A. And now let A axon be the symmetric point of A with respect to the line y equals 2x. So let's draw the line of y equals 2x. Now y equals 2x, when x is 0, y is 0. When x is 1, y is 2. So 1 and 2. When x is 2, y is 4. 3, 4. So this is line y equals 2x. And now they say the A axon is the symmetric point of A with respect to the line y equals 2x. So the point of A is somewhere around here. So they are symmetric, same line, same direction. This is point A axon there. What they ask is, we have to find the area of this triangle OA connecting to OA axon. So the area of triangle OAA axon. So how to find this? We did not need to find this point of A axon, because this triangle of OA here is the same as this triangle, right? So we need to find this area, and then we just multiply it by 2. Okay, so therefore we need to find this point. Let's say that is point X. So how to find that? Thing is, if this line is y equals 2x, and we connected this line, this line from A axon to A is perpendicular to line y equals 2x. So we need to find the gradient. Remember that one line has the gradient of 2. Therefore, the gradient of the perpendicular line is m1 times m2 equals minus 1. So 2 times m2 equals minus 1. So m2 is minus half. So the gradient of perpendicular line, this one, A axon to A, is minus half. And remember that the perpendicular line passes 3.1, the coordinate of A. So we can find the line there, that is y minus y1, the gradient x minus x1. This is the formula if you want to find the equation of the line, where you have the gradient and you have the coordinate that the line passes it. So this is y minus 1 equals the gradient minus half x minus 3. So that is y minus 1 equals minus half x plus 3 over 2. We just like this. Then 2y equals minus x plus 5. So this is the equation of the perpendicular line. So we just need to find the point of intersection. The way to do it is to use the elimination method. So we use this one, and we use this one. Because y equals 2x, so 2, we change to y to 2x equals minus x plus 5. 4x equals minus x plus 5, so 5x equals to 5. So 5x equals 5, so and x equals 1. And now we get 1, so we get y. We get x, we get y, so y is 2. So this here is the point 1.2. Now we need to find this area, this length, and this length, and we got the area of the triangle. Okay, so let's redraw that in a simple triangle. Let's say this is our triangle. Okay, so that is O 0.0, and we got x 1.2, we got A 3.1. We can find this length with the formula of x coordinate being subtracted and squared, and the y coordinate squared. 2 squared plus minus 1 squared, which is root 5. This is root 5. And for this length, this is the same. The x coordinate 0 minus 1 squared plus by 0 minus 2 squared, which is root 5, right? And then this is root 5. So the area of this one, just this half triangle, is half times root 5 times root 5. Because we have two half triangles, so we just multiply it by 2. The answer is 5. Okay, so that is for number 8. And now let's go to number 9. Number 9 is about the sequence and series. So let's say a sequence with the bracket a sub n, and they have the condition where a1 equals 3, a sub n plus 1 equals 2a sub n, and it is for n 1 to 3 until infinity, and we need to find the value of the sum from n equals 1 to 5 of a sub n minus 5. So this is pretty much simple, that you just, because this has a finite value, you just substitute the n. So that is a1 minus 5 plus a2 minus 5 until 5, a3 minus 5 plus a4 minus 5 plus a5 minus 5. So that is a1 plus a2 plus a3 plus a4 plus a5 minus 25. So we just need to find the value of a1 until a5. So we just use the identity that is known from the question. They say that a1 equals 3 and an plus 1 equals 2an. So if we inserted 1 plus 1 equals 2a1. So a sub 2, the second series, the second sequence is 2a sub 1, 6. So a3 is 2 times a sub 2. This 2 times 6, 12, right? And then a sub 4, which is 2a sub 3, which is 2 times 12, 24. And a sub 5, which is 2a sub 4, equals 2 times 24, 48. So from the calculation just now, we get a2 plus a2, a1 plus a2 plus a3 plus a4 plus a5 minus 25. Just 3 plus 6 plus 12 plus 24 plus 48 minus 25, just 68. So that is the answer for number 9. And now let's go to limits. Number 10. The limit of x to 0 of root x squared plus 4x plus 5 minus root of x squared plus x. Now how to do this? In the limit of root something, root quadratic equation and root quadratic equation, this is the general form, ax squared plus bx plus c, right? Quadratic equation, and minus quadratic equation, that is ax squared px squared, let's use this, qx squared plus r, this is qx. The value of this, that is if a equals p, the value of the limit is b minus q over 2 root a. This is the quick formula. So b is 4, q is 1, you use the constant, right, over 2 root 1, which is 3, 4 minus 1 over 2. The answer is 3 over 2. For number 11, fx equals cosine x over root of constant e to the power of x. We need to find the derivative of x to 0. Now, let's assume this one u and this one v. Now, the derivative of u over v, and u or v is a function. This is equal to the derivative of that times v minus u, derivative of v over v squared. So the derivative of cosine x is minus sine x. You have to know this. And the derivative of e to the power of x and rooted. Remember that this is equal to e of x over 2. Okay, so how to calculate this? Remember that e to the power of fx, the derivative is the derivative of fx itself times e fx. So the derivative of half x is half, right, e of x over 2. So that is for v xn, but we just use v here. So e x over 2 minus cosine x, and now we use this half e x over 2, and now divided by this is squared, so e to the power of x. And for the x equals 0, so f0 is minus sine 0, e0 minus cosine 0 times half times a0 over a0. So that is 0 times 1. 1, cosine 0 is 1, times half over 1, which is minus half. Okay, so that is for number 11. And now for number 12. Number 12 is about the integration. And this is interesting because we have the logarithm inside the integration. Integral of the limits of 2 and 1 of 3x squared minus 4x logarithm with the base ex. Remember that logarithm with the base e is just the natural logarithm dx. So how to find this calculation? It is pretty much simple here. We just use the di table. Do you know what di is? Di pretty much is just the differentiation and the integration table. You pick one of these, which one you want to use here, but you have to use correctly. I use I use the integral of ln x. I use this as a differentiation, so ln x, and this will be integrated. This is actually the quick formula, the quick way to solve this seemingly complex problem. So the derivatives of ln x, so we call it ln, natural logarithm x. Remember, it is always 1 over x, and just we integrate it as well. So we integrate this one, 3x squared minus 4x. This is just equal to 3 over 3x cubed minus 4 over 2x squared. Okay, so this x cubed minus 2x squared. Don't worry about the plus c of the constant. This is actually equal to x squared minus 2x squared. Now, how to find the solution here? Now, the way you do it is you multiply this. Okay, so that is x cubed minus 2x squared. You multiply by ln x, and you minus with the integral of this one, 1x times 3x cubed minus 2x squared. Just be careful with this di table. You multiply this, okay, directly multiply, and you minus the integral of this multiplied by that. So that is for one condition. Okay, so we just calculate that. 3x squared minus 2x dx. Okay, and now we just calculate this integral. This is equal to x cubed, right, minus x squared. I hope you get that, the value of this integration of 3x. I think this is x cubed. This should be over 3. Okay, from here, right? I think I missed that. Okay, and now we just insert the limit of 2 and 1. So we inserted the first two. 8 minus 8, 0, 0 ln 2 minus 8 over 3 minus 4. This is for one side, and you subtracted it with the another limit. 1 minus 2 logarithm 1, okay, minus 1 over 3 minus 1. This is 0 automatically. 0 minus 8 over 3 minus 4. So 8 over 3 minus 12 over 3 minus 4 over 3 plus 4 over 3 minus, this is minus 1. Remember that logarithm, any logarithm with number 1, always 0, right? Logarithm 1 is 0. Logarithm with base e1 is 0. Okay, so natural logarithm of 1 is 0, minus 1 over 3 minus 1 is minus 2 over 3 plus 2 over 3. So that is 4 over 3 minus 2 over 3, which is 2 over 3. Okay, so that is everyone for for part 1 of KOSEN Math 2016. Thank you for watching.